Good afternoon, everyone, and thank you for joining us for the second and last panel this afternoon. So it has been a very long day of very interesting insights, and I'm very happy to chair this panel session on scientists beyond borders. So before actually starting to talk about this panel session, just want to first introduce ourselves to you. I am Fatemeh Jalayer. I'm a professor of geophysical hazard risks. I've joined recently UCL IRDR, and together with me, I have our wonderful panelists for today. I'm going to briefly introduce them, but then I will actually ask them to introduce themselves in a more detailed way so that you can get to know them and their background. We're very pleased to have with us today Dr. Carla Washburn. She's an associate professor in environmental science and policy, UCL. We have Dr. Daniel Haynes, who is very soon actually is going to be a lecturer in disaster and crisis response with us at IRDR. So it is also a welcome to Dan. We are very pleased to have with us Dr. Anavat Supastri, who is an associate professor at International Research Institute of Disaster Science, IRDS, at University of Tohoku. And we are really privileged to have Anavat with us since he's right now visiting UCL and IRDR. And so it is great to have all of you with us today. And thank you, the audience, for the attention. So I'm just going to provide a brief introduction into the theme that we are covering in our discussion today, and a little bit also about the format of this panel discussion, which is going to be a little bit different with respect to the one before. So we talked a lot about the challenges we are facing, and you've all heard several times words such as the climate challenge, the environmental deterioration, the disasters, conflicts, and the crisis coming up during the day. And we also had the privilege of hearing various insights about different actors in this. Like we talked about the law and legislation. We talked about the finances. We talked about humanitarian organizations. And we also obviously talked about decision makers. A lot of times we also talked about politicians. So we really talked about different actors in order to tackle these problems. So it seemed to me, clearly we discussed also oftentimes today the several boundaries and the several barriers that existed in order for these actors to be really effective in order to tackle problems such as climate change, the disasters, crises, and conflicts. And so clearly we are all thinking about the difficulties that exist and the common wish for us to come together and tackle these problems together. So it seems very timely also for the conference today to kind of bring back the discussion to us as scientists, as researchers, of different fields, of different disciplines. So how can we help in all of this? How can we provide some insights in trying to be together and to tackle these problems together? Clearly, we also talked about the different boundaries that exist, and we talked about the boundaries of some sort of, let's say, physical boundaries, geographical boundaries, the historical ones, the cultural ones, the beliefs, the linguistic ones, the boundaries that are caused by inequalities of not everyone having access to the same kind of privileges. So I can really talk and provide a very long list of boundaries that can divide us. So with that, I actually would like us to focus in our discussions today about what have we in common and how can we actually kind of make the most out of the sense of urgency that characterizes this moment, because of many reasons we feel we are in an urgent moment. All of us somehow feel that we would like to contribute with our research in different ways and try to solve the many problems that we feel that kind of somehow the clock is ticking on them. So with this, I would like to actually start our discussions, but first of all, a little bit about how the panel discussion is organized. So I'm going to actually first ask our panelists to introduce themselves in their own words, so that you also get a sense of how interdisciplinary our panel is, the different type of expertise that we have at the same table, so that we can look at the same problem from different angles. And after this round of introductions, each one of our panelists is going to discuss like the several cases of where there has been boundaries or where boundaries have been actually been overcome, how scales have been overcome. And after that, after each talk, we are going to have questions from both the panelists and also from you. So that was just to give you an idea of how the discussions are going to be organized. So with that, I'm just going to ask Dr. Carla Washburn to start introducing herself. Thank you.
Sure. Hopefully everyone can hear me okay. So I am Carla Washburn. At the moment, I am an associate professor at UCL. But previously, my training was in natural sciences, so earth science and engineering to start with. I essentially lapsed a little bit from geotechnical engineering and geosciences into the policy space, and really have worked at that interface ever since, I suppose. So the examples that I'm hoping to talk through for just a short while as an intervention to this panel are really in that space. They're interfaces between mostly environmental science and policy.
Thank you, Carla. Thank you very much. Dan, can you
Hi.
listen?
Thanks, Fatima. Yeah, I'm Dan. As Fatima kindly mentioned, I'm about to start here a week on Monday as a lecturer in disaster and crisis response. I'm currently at the University of Bristol in the history department, and by background and training, I'm an environmental historian, which simply put is the study of how humans and the natural environment have interacted in the past and how the two have influenced each other. And I tend to specialize on modern South Asia, so India, Pakistan, a bit of Nepal, in the 20th century. And I've done a bit of interdisciplinary work with geoscientists, other kinds of environmental scientists, social scientists, NGOs and policymakers. It's big teams, as we will discover, in Nepal and Bhutan. And I'm also the author of many, or rather co-author of many failed bids for further funding to work with environmental scientists and social scientists in the Himalaya. So I'll be talking from the perspective of somebody who has, in some ways, a fairly traditional disciplinary history background, but also trying to engage with the kind of big questions and mixed methods that you use here at IRDR.
Thank you, Dan. Annabelle, please.
Okay, thank you once again. Thank you for your invitation. It's my great honor to contribute to your annual conference while I'm visiting here. Our institute is actually just established 1 year after the 2011 tsunami, which is 2 years after IRDR, and we are doing things interdisciplinarily. We have not only engineering and science, but also medical science and like history and so economics and things like that. Myself, civil engineering by training, and my focus is on all perspectives of tsunamis. So, so like here in this panel, we have also people from science, as a science geologist. We are doing tsunami deposit studies, and we are also working with history professor who is reading like difficult old characters of Japanese. In Japanese, and also as an engineering, we are doing simulation. So we are doing this kind of interdisciplinary to fight against, for example, one big tsunami in the past. So this kind of thing is really by nature. And for today, I would like to give you some idea using a tsunami as an example of the hazard, that how international community in tsunami community, how we work and how we contribute to our society and resilience. Thank you.
Thank you. Thank you very much. As a short introduction to Carlos' presentation, I would like to actually dedicate some words to the climate challenge. It feels very global. I mean, we're all talking about it. We hear about it a lot. And clearly, it is one of those things that seems to actually be some sort of a common language where all scientists somehow are from different angles talking about. But at the same time, the effects of it are quite local. I mean, in many ways, they are going to affect our lives, our personal lives, not necessarily our professional ones, but it's something that we have touched. So it really seems fitting that any kind of activity that is going to start to look into solutions is going to actually cover different scales, like starting from a global level to a regional level, and then to the global actually scene. Another point is actually the interface. I mean, like talking about boundaries that exist. One boundary, which would be sort of like one of the biggest one for scientists, is to actually breach the boundary towards policies, because clearly we would all want to make our work have an impact. And obviously that boundary sometimes seems actually can also be a wall. We might feel that we have difficulty in actually crossing that boundary. So it seems to me very fit and very timely to have Carla kind of talking about her work and how this boundary between science and policy can be overcome, and how different scales can be traveled across. Thank you, Carla. So maybe I help you to that.
Speak a little bit about 3 examples of science policy interfaces on the environment. And I realize I gave a very, very brief introduction to myself, but hopefully this unpacks a bit of what I do day to day, to which the best description is complicated. All of the work that I do, I say, is interfacing between different entities. And actually, I think this introduction was wonderful and sort of saved me a little bit from going too much into the definition that I was going to give on science policy interfaces. The reason I put this up, I think, was to remind me to say that science policy interfaces really talk about these relations between scientists and other actors in the policy process. But this is a variety of different actors. So the examples that I'm going to be giving are not just scientists interacting with parliament, legislatures, government, but interacting with lots of different actors who all interact within the environment that influences the making of policy. So some of these are going to be a little bit more arm's length, and some are more directly perhaps with the people that you would think of when you think about policymakers. But the idea behind these interfaces is they're places where there are exchange, there's co-evolution, there's co-construction of knowledge, and the idea is that we enrich the decision-making that comes out at the end of it. Really, these 2 definitions are saying very, very similar things, but I've included the second one because this does give a bit of sense of hopefully still having some semblance of speed to this, so that actually these are processes which can hopefully operate at speed to get things done when there are very significant time pressures in taking action. Okay, so the 3 examples are going to kind of build from very local to global scale. And I thought what would be quite nice is really just to walk through what these interfaces were, just give you a sense of how they can constituted, what they're supposed to do, some of the challenges that exist within them. And then at the end, if I have time, and I'm going to try to have time, I'll talk quickly through some general kind of challenges and opportunities, because I know that was one of the framings for this session in particular. So at the smallest level, there's this entity called the Green Space City Lab for London. This is something that I helped to set up a few years ago now, in 2020, with the London National Park City Foundation, which I hope you've heard of. And if you haven't, please do look them up, just generally, because if you're based in London, they're wonderful and do amazing stuff with promoting green space in the city. It was a very small space. It was 20 to 30 people. And the reason it came to be was because I kept encountering people working in green space in London who all said, we don't have anywhere to talk about green space that's not a specific project or somewhere that I have to say a certain thing, where I can just come in and say, here are all these problems, here are all these great things, and actually, what can we do with this collectively? So that's what this was. It was an informal space, a regular gathering of people working in and around this topic. It was proximate to policy in the sense that there were people from the Greater London Authority, there were people from local authorities engaged, but this was everyone from arts practitioners, engineers, planners, landscape architects, and the policymakers in that as well. And as I say, it was as open-ended as that, really. We had a topic of shared interest around green space in London, making it better, but we didn't really set anything more prescriptive than that. And what was kind of great is that this did evolve over a number of meetings to develop ideas about making positive change in the city. So we do have some things that we've documented, which I'm very happy to share, to do with actually how different entities can work together and actually mapping entities to get people knowing who's doing what in the city, but also just actually connecting those people who probably hadn't met before in this space. There were some challenges with this. The scope and the remit were problematic to set because it was so open-ended. We knew that we had a general sense of what we wanted to do, but it wasn't prescribed from the beginning. Part of the beauty that we co-developed it, but part of the challenge that it could kind of go anywhere, and it was difficult to know what level of intervention to give that. Time and resource commitment. This is going to come up again for the next one. We were all just committing our time because we cared about the topic. We weren't being paid to do it. We were doing it kind of our own volition. So that was a challenge. I think a lot of people working across science policy interface work aren't necessarily formally recognized, although it's improving for doing so. But also keeping momentum going of something like this, something that had that reason for being, took particular individuals and particular groups to push it forward. So I'm going to say it's on hiatus right now because simply it's hard to keep momentum on something like that, but also because I think we did reach a consensus of, we know who's in the room now, and actually we can come back to this when we have more questions or want more discussion. I'm going to try and whip through the other two very, very swiftly because it took longer than I intended to on that. Please do cut me off if I'm overrunning. The second interface is at a kind of regional level, so this operates at the European level. It's an interface called Eclipse, or the Eclipse mechanism, as it was previously known. Has a core team of about 40 people, and it has more prescriptive aims and objectives than the previous example. So this entity was established with European funding originally to answer questions from decision makers by synthesizing evidence, and really kind of synthesizing the best knowledge available on biodiversity and ecosystems. There's a facilitation that takes place through a request process. So actually decision makers across Europe can make requests to Eclipse to say, we need evidence on X. Are you able to help us with this? And Eclipse will then go to people like myself, so there's my face, along with some colleagues at the bottom here, who are part of the knowledge coordination body of this entity to say, can we? Actually, do we already know this? Do you know that this evidence exists somewhere already? Are there materials that you can bring up for us, or is this something that we need to do? If this is something that we need to do, we commission groups of experts to actually create these materials. And there is one soon to be hot off the press on biodiversity and pandemics. So this is often stuff that's very responsive to topics that are happening or have just happened at the time. Again, there are challenges to this. Again, the main one is time and resource commitment. Many of us are doing this voluntarily alongside or on top of academic positions. Actually, not all of us are academics, so many of us are, but some are independents, either working on projects themselves. There are people in agriculture, etc. There are people independently working in other institutions. but also duplication of effort. So working at this kind of scale, even having this process in place for trying to triage questions in and get a sense from as diverse a group of people as we can find across Europe as to whether we already have answers out there. We do find ourselves in the middle of a process sometimes, and we find another body is doing the same thing or something very, very similar. So there's a lot of coordination between networks of networks, almost between different bodies doing science policy work. And the very final one I'm going to talk about, I'm not going to walk through the request process, but that's just to give a sense of it's pretty detailed and pretty rigorous, and the way those requests are triaged and answered is IRDS. So the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services, established in 2012. This body operates at the global level. It's more commonly known, I suppose, as the IPCC for Nature. It operates in some similar ways to the IPCC, if you're more familiar with that model. It has 114 member states. It's a very big entity. It will have its next plenary this summer, so it does have regular plenary meetings and other activities that take place beyond those. And the major things it best does, if you're not familiar, is it conducts assessments. So you may have seen a global assessment released a couple of years ago. It was very, very much in the press. But they have done thematic assessments, regional assessments prior to that. So again, it's an entity that generates knowledge products to put out into the world about biodiversity and ecosystem services. It does a lot of policy support with its member states, both developing tools and methodologies to support the integration of that evidence when it is generated, capacity building along a similar line, and actually a lot of communications and outreach just to get the messages out there too. There are challenges with IRDS also, so as I say, I'm going to quickly summarize these at the end, but in terms of knowledge to action, obviously really, really tricky. I think one of the main things that they are recognized for doing is these big assessments, be it global, thematic, regional, etc. But to actually then have something done with that is trickier. So I think this has been one of the things that IRDS has been really focused on, actually taking that knowledge into action. And also the simple pace that you can do things at when you're a really, really big entity with lots and lots of processes and lots of people involved is just the pace at which you can operate. I wonder if I should just leave this up for a moment, because I can have people read this through. I realize this is a wordier slide than I would normally put together. But this is actually taken from a paper that myself and some colleagues put together a few years ago. It's the opening paper to a special issue on science policy interfaces around biodiversity and ecosystems. And we tried to set out some general opportunities and challenges as we saw them. And I think actually these tally with some of the things that have been said about the previous discussions. So challenges really just being highlighting what's going on, giving the scope of what's happening in terms of the deterioration of the environment and the consequences, addressing the interconnectedness of ecosystems and people to tackle the planetary crisis and be able to communicate this through a kind of systemic perspective across scales. Dealing with the complexities of science policy interfaces, I've given 3 small examples on a similar topic, and they all have their own trickinesses. They all, perhaps intentionally, don't really integrate with one another, even though there's ways in which they kind of overlap in the realities of the world that we work in. And the last one maybe is one that we can talk about a bit more, and I guess we will talk about more, the kind of transformation or the positionality that scientists have in this evolving space where, yeah, it's becoming more and more urgent that we listen to the alarm bells and actually act on them. Maybe I'll leave it at that. Sorry.
I just wanted to ask Carla to a little bit elaborate on the final point where she left us with to think about. And so, how do you think we as scientists can really, in a concrete way, realize that sense of urgency that there is? And how can we act in a timely manner and not be lagging behind in our, let's say, own constructions?
Good question. I realize what I just presented probably gives a sense of what I'm trying to do. And I think a lot of colleagues I see are doing a similar thing. And a lot of that is, what's the phrase that I'm looking for? It's kind of, it's spreading yourself out, I suppose. So it's recognizing that actually you can and should engage with things at as big a scale as you possibly can, if you can be involved in these processes at kind of regional and global level, that actually we kind of need to be acting at every single one of them. So I suppose I've quite consciously tried to sort of spread my effort, as it were, across different scales and different spheres, because they are all acting and reacting in different ways at different paces. I don't know if that completely answers you.
Absolutely,
Yeah.
absolutely. So yeah, it kind of shows how, let's say, horizontal everything has become, including us as scientists. We have to kind of not to be less focused, but to kind of realize that we need to also be more active in working with others, I think. Yeah, so absolutely, absolutely. Obviously, I have other questions, but I just want to first ask our panelists whether they have questions. I give them this privileged position before the audience. Dan, please.
Thanks very much, Carla. I've just come back from a 2-year secondment to the Foreign Commonwealth and Development Office, where I was in one of the ex-Foreign Office bits rather than one of the ex-DFID bits. So my job wasn't really to deal with science or development questions directly. But I did see there was a definite cultural difference between the ex-DFID side, where evidence, including scientific evidence, is taken very seriously. And colleagues on the development side made heavy use of knowledge for development, which sounds quite similar to Eclipse. But it's run out of the Institute for Development Studies in Sussex, in case anyone here doesn't know. But that mechanism of directly answering questions that decision makers are worried about right now in a quick manner seems really essential to the uptake of science or evidence from social sciences and humanities more broadly in decision making. But it also relies on people within those institutions already having the awareness and the knowledge to ask the right questions. So I was wondering, in your experience, how do you sort of engineer the people in those institutions to ask you what you think they need to be asking?
Yeah. There is a lot of dialogue, I should say. So there is a lot of dialogue at the beginning. So the process that we normally receive questions through is an online process. It's not always. There will sometimes be conversations that happen in meetings and venues and in places. But yeah, most of them will come online. But yeah, generally we'll have a series of conversations with the people who've made the submissions. And we will, in part, try to get to understand, as I said, like, firstly, does this exist somewhere? And it's actually just, it hasn't been identified, so maybe is actually an even quicker win for the people requesting. Sometimes, yeah, we do end up having a bit of a to and fro on, is the question answerable? Like, can we answer the question with the resources we have, with the methods that we have, with the kind of scope and remit that we have as individuals? So I think it's often an interplay of, yeah, sort of trying to address the core kind of thematic topic that has been requested, but actually recognizing that, I suppose what I'm getting at is if an appreciation of, if you want something to be done quickly, perhaps you're not going to do a systematic review. So a little bit of a balance of what's possible in terms of the methods that we have available to us to be able to answer those kinds of questions in the ways that we would normally do within academic research. So I suppose that's often quite a part of shaping the question as well. I mean, the thematic scope doesn't tend to go too awry, because I think we are very bounded within, it has to be within Europe or within a country in Europe, ideally something across Europe, but even if it's one country that's further applicable, it has to be on biodiversity and ecosystems. So I think there are questions that automatically get scoped out because they're completely not within that remit. But for example, the biodiversity and pandemics was an interesting one, because that came from, as you can imagine, like a whole cascade of questions that related to biodiversity and pandemics, but some of which were incredibly open-ended that actually would have been really challenging to answer or were being answered elsewhere, down to things which were, very policy prescriptive. So they were really wanting something that would recommend exactly what course of action to take, for example. So again, we have to kind of have that conversation of, we exist to generate knowledge, but not necessarily to tell you what to do. Yeah.
Thank you. Other questions from Anna?
Yeah, if just in case if you could share your experience. So this probably related to what joint research that I'm doing with Joy and Rebecca about tsunami warning in Japan. Well, as a scientist, we know okay, what is the risk of things, but as a policymaker or kind of the government agency who's in charge of giving the warning, they would like to make sure that no one will be killed by these things. But for us, we would like to minimize non-necessary evacuation or non-necessary the disturbance of the like processing of things in the business. So yeah, this kind of conflicts or kind of mismatch between scientists and policy making or potential. Do you have any experience? For me, still we cannot solve this kind of problem. But if, based on your experience, if you have any sort of thing could share to us.
I'm trying to think of good examples.
Quite difficult question. Oh, you're
thinking.
Yeah, just because, as you say, like it's there's a very different level of certainty that we're prepared to exist with often in these spaces. Yeah, there's not one that immediately jumps to me, which is like a really good example of where we've kind of resolved that. I think there's been some wonderful work done on the processes of how we do resolve that. So I know that certainly within our teaching, and I think we have updated this because I know the original of this was published some time ago, but the PBL Netherlands, the Dutch Environment Agency, did some really wonderful stuff on uncertainty communication, trying to build kind of matrices for how we, I guess, understand different elements of uncertainty and communicate those between different actors. So I know that there's some really nice process stuff. I can't pick out a really good example of action.
Thank you. I think maybe we need more communication or give knowledge to local people or stakeholders to understand more what is behind the reason of that. Okay, thank you.
Thank you. So now we can actually take a question from the audience. See a hand, maybe can give the mic.
Very interesting discussion, but I'm not sure we actually accurately captured what the problem is within that configuration. Just to highlight the last point, the divide between scientists on the one hand and policymakers. I don't think it's like that at all. I mean, so many examples would counteract that. Just to give a few, the 2008 economic crash, the Queen went up to the LSE and said, why did all the economists fail to predict this? In Fukushima, which was just highlighted, Germany was abandoning their whole nuclear project as a result. In the UK, we amplified it. The power circuitry crosses that divide by 1,000,000 miles. There was a famous Bishop of Durham who said that, if there was a flood in Bengal in which 5,000 people died, that headline on the BBC would be 2 Brits got their hair wet. This is the configuration we're dealing with. Moral conflict is at the heart of this. And in reality, it's moral privilege as advantage against moral praxis. And if it's going to be moral praxis that wins, people have to lose. And large numbers of people and institutions will have to lose. And who's going to be coming forward for that?
So, is the question clear?
Not so much. I mean, as a comment, I completely take your point. I don't know that I can respond to it as a question.
Yeah. So was it a question or a comment in the sense that do you think
Yeah, Elon Musk is planning to evacuate to space and, take a few of his fellows with him. But that's how the situation is.
Okay, thank you, actually. But can you introduce yourself also? Because I think, yeah.
My name is Heli. I'm an independent researcher and curator and archivist. I document these kind of configurations through art and sound. But for me, in my understanding, it's really an installation that we're able to exhibit. We're not able to exhibit concrete normative change because it's power which is so beyond our possibility. The power circuits within the world which define all of these decisions, they're not just divides between science and public policy, they're divides between resource allocations, the way in which asymmetry provides its own generation of power. And that's the definition within this, I don't know, it's like a kind of industry now of disaster prediction, We failed to predict every disaster going, and we keep predicting even more, but they just come, evacuate whoever they evacuate, and then it's the next one.
Yeah, thank you. Thank you. Clearly this kind of focuses on the inequalities very clearly. And do you have something more to say?
I can. Again, I think I'm probably just building on what you've said though, and I absolutely don't disagree that the power asymmetries play out enormously. And I recognize we're focusing on a kind of science policy interface here in a very kind of caricatured way, as it were. So recognizing that everything we say is, as I say, the examples that I gave, I tried to situate within those three spaces. But actually, of course, science policy interface and all of these interfaces are bigger than what we can cover just now.
Yeah. It is also about what we can do as scientists. And clearly, I think it was also said in the morning that to try to be optimistic and try to take one step at a time and try to improve. And I think knowledge always improves. I mean, so that is from a scientist point of view, clearly. I wish I could take more questions from the audience, but we kind of need to move to the next presentation. And then clearly, if there is time, we're going to take more questions. And obviously, you can grab Carla after the session to ask your questions. So Dan, please.
Thanks, everybody, and thanks for sticking with us to this point in the afternoon where I suspect much of the energy and enthusiasm that carried us through the morning might be dissipating, but you are stalwarts, you've stuck it out. I admit I had a moment of panic when Fatima told me what the theme of this panel was, because my first thought was that I should provide some examples from my historical research of the power of science overcoming boundaries between people, be that people from different communities, people across geographical divides. But unfortunately, all of the work that I've done in this space is about how science and engineering has failed to overcome divides in the context of international river water disputes between India and Pakistan, where the fact that the cohort of engineers who are dealing with divided water after those two countries' independence and partition in the late 1940s came from the exact same engineering schools and had worked very closely together as colleagues for some number of decades and then could not agree on an equitable settlement of water. And that is a problem that still plagues international relations today. But fortunately, it turned out it was okay for me to talk about some of my own experience trying to be a historian crossing different kinds of boundary, be those disciplinary or geographical. And that's what I'm going to talk about today. So I'll start with my conclusions in case I run out of time, because that unplanned anecdote about engineers has taken up a minute of my 10. So there are two basic roles history can play in hazards and disaster risk reduction research. One is what we might broadly call social analysis, and in that I would include economics, policy,
culture labels as a matter of choice to an extent. And that is the traditional domain of the humanities and social sciences. I do hope that wasn't me. And the other is what we might call data mining. So using historical tools and methodologies to extract data about past hazards which colleagues in the physical sciences can use. And I'm going to outline each of these modes very briefly today. To work effectively with historians, we need really quite well-targeted interventions. Historians aren't always the most relevant person to any given piece of work, but when we are useful, we can be really useful. When you do decide to involve a historian in your project, it's essential to focus on relationships. So preferably co-working and really understanding each other's methodologies is absolutely essential, and understanding the constraints and mixed incentives. I mean, I don't want to get into a whole discussion about REF and impact case studies, but suffice to say that incentives differ across boundaries and across disciplines in quite important ways. And finally, that historians have a curious mixture of often quite narrow specialism in terms of region and time period. So personally, I'm most comfortable in 20th century India and Pakistan. And if you ask me to work on, I don't know, 16th century Southern Africa, I probably wouldn't be a whole lot of use. But within our sort of tram lines, we're used to being adaptable and flexible to a certain extent, and to attacking questions from a variety of different standpoints. So to take these two modes of historical research in turn, firstly, I'll talk about the project which I'm just sort of finishing up some of the research outputs, and by that I mean starting writing the book, which was a project on the social and political impact of earthquakes across colonial South Asia, which in present-day terms is India, Pakistan, and Myanmar, with a kind of nod to Nepal, which was not colonized, but was affected by one of the earthquakes. And it was funded by the Arts and Humanities Research Council. And I had a project partner based in Kathmandu, the National Society for Earthquake Technology. So in this project, I was using one of the key strengths of history, which is understanding change over time. And what I have found, and what my team has found, is that there was a definite shift in how the colonial authorities responded to earthquakes between the 1890s, when the first of these major earthquakes happened, and the 1930s, when 3 more occurred. And over that time period, the colonial state became much more interventionist. It did more, and it was much more ambitious in terms of its relief response and its interventionism in reconstruction. A lot of that is down to shifting global norms. So this is a period in which earthquake management and earthquake governance was becoming more established internationally. It has something to do with shifting public understandings in Britain among the public and in Parliament about the colonial state's responsibility for Indian lives and livelihoods, which mainly played out in terms of famine, but had some read across to acute hazards. But I focus much more closely on the dynamic relationship between the colonial authorities and anti-colonial nationalists. So most famously, the Indian National Congress, most famously led by Mahatma Gandhi. So within that broad trend towards greater intervention, it's also really important to emphasize a couple of things which we can draw out. The first of which is the highly contingent nature of responses to different disasters. So although there was this general trend, the actual political outcomes of different earthquakes could be very different. If you take the 1934 event in Bihar, the epicenter was actually in Nepal, but I focused on Bihar in North India. And the 1935 earthquake in Quetta, what is now Western Pakistan, which killed about 30,000 people. Although they took place just a year apart, the way that the Indian National Congress interacted with the colonial authorities was very different. So in Bihar, they worked very closely together. It wasn't frictionless, but it was a pretty effective coordination between a colonial government and the people who wanted to kick them out of the country, with pretty good reasons, we must say. In Quetta, just 1 year later, the colonial authorities declared martial law and banned Congress volunteers from even entering the damage zone. Congress protested as a result, and this was the only earthquake in late colonial South Asia which saw significant political contestation over earthquake response. And yet, even despite those differences in outcome, there were some commonalities between the way that the colonial authorities and some leading nationalists thought about earthquakes and why they mattered and why relief response mattered. And much of this has to do with how they envisaged the class composition of Indian society, but it also came down to a common conception of what hazards and what disasters were, and particularly the idea that disasters are caused by nature and the place of humans is to respond to them. And this means that there was no serious discussion about things like the root causes of vulnerability, the way that colonial economics produced poverty and put some people more in the way of harm than others. So the second use of history, what we might call data mining. So it's a pretty well-established practice, particularly in historical seismology, to use historical records to supplement the instrumental data, because basically we didn't have seismographs before the early 20th century or the late 19th century. And so historians can help physical scientists recover data about past events. And I was involved in some of this work in a scoping study in Bhutan, funded by the Global Challenges Research Fund, now dearly departed, more or less, which was led by Francis Cooper, a structural geologist at Bristol, who, as it happens, has also just joined UCL in the Earth Sciences Department. And we had a team which mixed social scientists, physical scientists, policy makers in Bhutan, and me, drawn from across the UK and Bhutan, and one of our engineers was on loan from India as well. So my part in this project was to tour libraries and what are called zongs, which are kind of a cross between a monastery, a fort, and an administrative center, and speak with the monks there and try to identify evidence they had from their historical records, so the archives they hold within the zongs, which could help illuminate past earthquakes. And this was a short scoping study, one of the at least two of those many failed funding bids that I mentioned, work and follow-up work. We haven't yet been funded. Any funders in the room, I will have your money if you are offering it. So don't ask me for definite results yet, but we at least had a proof of concept that there are real references to past earthquakes available in particularly biographies of religious figures. That's one of them you can see in the image on the right there, which either reveal new events, small-scale seismic events that we didn't already know about, or give better data on ones that we already did know about. For example, this is from an autobiography of a religious figure who lived through the 1714 earthquake. And this helps provide some data which, frankly, I don't really understand, but my physical science colleagues can use to input into their models. So this kind of work is really challenging because as a historian, I already outlined my limitations in the sense that I tend to focus on India and Pakistan. Bhutan, although geographically close, is culturally, linguistically, politically a very different environment. So actually, I knew much less going into this project than I would expect to if I was working on India or Pakistan. But at the same time, it was fantastically rewarding. For example, in this photo on the left, that's myself and my colleague Max Werner, who's a seismologist, speaking with a monk about this record in the photo on the right, and seeing the kind of questions that Max asked from his deep understanding of seismology, and comparing those with the questions that I asked with my historian's instincts was really productive for both me and Max. Not quite sure how much our respondent got out of it, but he was very polite and generous with his time. So I've already given my conclusions, which is lucky because I'm over. So it just remains to me to say thank you very much.
Okay, thank you, Dan. So just first of all, it was nice to see Max Werner because I have read his work, but I've never seen him. So that was nice that you have had that experience working with him. Actually, I asked this question as an earthquake engineer because it is very interesting to me to see this group of very interdisciplinary group of engineers, scientists, sociologists, and yes, also policymakers come together to work on seismic risk. So what was your experience? I mean, was it a smooth kind of let's say, interaction, or they were barriers in that?
Bit of both, in the sense that it took an awful lot of work to agree what questions we were going to pitch to the funder and how we were going to address them. And actually, the many hours that Max and Francis and Byron Adams and I spent sitting in various offices in the Earth Sciences Department in Bristol, knocking around questions, turned out to be really valuable in establishing what we did know and what we didn't know. So, for example, we would sit there and look together at previous published research on historical seismology in the Himalaya and in Bhutan, and they were able to explain a lot to me because I'm not scientifically trained. I didn't understand the physical processes, but I could also evaluate the historical evidence that went into those papers and on which claims were being made. So, for example, I forget now the detail of the case study, but there was one case in which the scientists were citing the authority of somebody who had lived through an earthquake as a 4-year-old child and decades later was writing an autobiography. And so I was able to point to the large body of work in oral history on how memory affects recollection, thinking about degrees of evidence and what's first-hand, second-hand, third-hand evidence, hearsay, and all those kinds of things, which are kind of very basic to my discipline, but not. And a lot of it's common sense, frankly. There's nothing mystical about historians and what we do. But if you're used to thinking about these things, they spring to mind more quickly, right? And that meant that when we got to the field, we had a relationship of trust between myself and my scientist colleagues, and also a reasonable sense between us of what we hope to get out of it. I will say that in some interdisciplinary work I've done, there have been tensions across the humanities and social sciences, there's nothing inherent about that again, and a lot of it comes down to people and priorities and personality. But in some ways, it's kind of easier to slot together a humanities subject and a physical science subject, which are completely different, because you start from the point of view that you have little in common and you need to build a bridge. Whereas when people in more similar fields work together, we often find that we're trying to do different things but using the same language, which just confuses us.
Yeah, exactly. Thank you. Are there other questions from our panel to Dan before we move to the floor? Carla, you.
Although I realize it's not a very technical question, but I'm just fascinated from the last image you showed. What were the most, I suppose, unusual or kind of surprising lines of evidence that you found in this scoping that you were able to use?
I think it was these biographies of religious figures, which are a type of source that I wasn't familiar with beforehand. So the archives I normally use tend to be government generated or memoirs of individuals or sort of private papers of people, which are catalogued in quite familiar ways to my kind of UK upbringing. But in Bhutan, there was no tradition of archive keeping in that sense. So there weren't government records per se, in the sense of kind of administrative archives, which departments generated. And so the main sources of history that Bhutanese scholars use to write the history of Bhutan are these biographies, which, because they center on individuals, but they encompass information about other things that were going on. And so you can catch references. Actually, Kama Punso, who was one of our partners in Bhutan, who runs a kind of cultural heritage organization there, was planning to organize some scholars fluent in classical Tibetan, Choke dialect, which is what was used in Bhutan, to systematically go through some of these biographies and the scoping work he did turned up a lot of references, not just to seismic hazards, but also rain-induced landslides, flood events. There's a whole rich repository of data there about Bhutan, but it takes an incredible level of scholarship and learning to access it. So, even an ordinary Bhutani would not necessarily have either the language abilities or the understanding of the very specific genre conventions and writing styles of those religious biographies in order to actually understand what they're saying and to triage what are sort of allegorical references to what look like geophysical processes to actual records of things that happened, if that makes sense.
Thank you. Anna?
Well, yeah, I have several questions, but just for the time, just choose one question. So, like in my case, we are talking about more older document. I'm not sure. Like for example, your case in Pakistan, still you have photographs, so we can sure this is a certain damage or um, kind of record. But like your example in Bhutan, it looks much more older. So my question is that how would you um, make sure, or how do you classify the reliability of the document? Like for example, we talk about tsunami or flood, maybe in the old record say, okay, the water reached this step of the temple or reached that hill, something like that. Sometimes in the historical, they probably say too much, like too over talking like that. So in your experience, how do you have any experience about that, or how would you classify the reliability of the document?
Thanks. In Bhutan, I am basically reliant on our local partners who have the understanding. I don't remember very specific technical data, so it'd be more like identifying that there was an event which in their subjective perception was serious or not serious. If it was serious enough, if it was a big enough event to be in a religious figure's biography, that probably means either it was smallish but highly local to wherever they were, or it was something national scale if it wasn't local. And kind of understanding the difference requires, as I said, a lot of contextual knowledge. For colonial records and post-colonial records in India and other successor states to colonial India, actually those were highly modernist bureaucracies that kept a lot of scientific records. So for the 20th century, I mean, you as a scientist would recognize, if I gave you one of the Geological Survey of India's reports from 1897, you would be able to go through that and very easily pull out the data. And they also, the GSI in particular, were very careful about recording the reliability of their data, which maybe we should talk about it afterwards because I'm out of time. But I've got some good stories in that.
So I would like to also take questions from the audience. Are there questions? Yes.
I'm Sobia, and I'm from Pakistan, and I'm doing my research on climate history of particular region which is disputed part of Pakistan. It's mountainous, and hazards and disasters are like usual phenomena for us. So I was wondering, as a historian, when you'll go and when you try to rely on historical records, and you mentioned that colonial records which are kind of modernist and perhaps reductionist in nature, and how did you try to integrate those cultural imaginaries or indigenous perspectives which may be different than those colonial records? Again, the power imbalances still exist which try to suppress and dismiss indigenous voices. For instance, people wouldn't assume earthquake as maybe not disaster, maybe for their imagination it can be a different thing. So how do you try to balance that view? Also, being an outsider and historian, how did you try to build that trust, or how did you try to maneuver your standpoint in those particular regions or areas?
Can I ask which district are you from?
I am from Hunza, which is in Gilgit-Baltistan, Karakoram mountainous ranges.
So Hunza is an interesting kind of counter to my big claim about colonial record keeping, because about a third of what is now India and Pakistan and Bangladesh was under what we would call princely rule, so not under direct administration of colonial officials. And actually Hunza was one of those, as you will well know. So you don't have the same kind of record keeping for areas like Hunza. But in a way, the kind of history work I do is not ethnographic, so I don't spend most of my time going and talking to indigenous communities. I spend it sitting in archives in Lahore or Delhi or London a lot of the time, because colonialism. So Britain acquired a lot of the records about India and Pakistan. And actually, one of the limitations I found with my earthquakes project is that I began with this grand conception to study many earthquakes with a small amount of resources and a small project time frame. And actually, to really properly tell the story of any one earthquake, you would need much more intensive research in a range of languages with a range of local expertise. So frankly, I wouldn't tackle the definitive history of an earthquake in Hunza. And I was pretty limited looking at the Kangra earthquake of 1905 and the Shillong earthquake of 1897, because those happened in areas where there was a relatively low imprint of the colonial state, and local literacy at the time was not very strong, and I didn't have the time or expertise to go and do large-scale oral history or sort of folk memory research. I could go on about that, but I probably shouldn't. Really time.
Okay, thank you. Actually, I have to move on to our third and final speaker for today. I mean, we actually had tsunami being discussed earlier today, and so I think the topic does not need introduction, but here we are talking about a phenomenon that is literally global, in the sense that the waves of tsunami literally travel across the world, and consequences that we have heard also from different people today mentioning really go beyond the borders. So let's see what Annavat can say about us from the experiences of a country that really has suffered through tsunami events, and a country to which we really look up to for a culture of prevention and preparedness and discipline to tackle this problem. So with that,
Okay, thank you once again. So this is the topic that I was assigned for today's session, and thanks for patience and stay until the last talk for today. So I would like to well, as you mentioned, well, tsunami is probably the only natural hazard that is called in not English term, probably. Maybe. Yeah, so yeah, that is another reason why I choose to study about tsunami in Japan, and that this is I would like to use this phenomena as the example how our scientific community, how we work together to try to reduce the damage or things in the future. Talking about our community, we have started our what we call International Tsunami Survey Team since 1992, the Karuko tsunami. Because as Ferdinand mentioned, tsunami could go everywhere. It's a water body, so we need like international collaboration to do the survey. Many of tsunami events is beyond the local that country to to have tsunami scientists or experts to do the field survey, the right survey. For this, with the UNESCO IOC, we are also publish kind of a manual guideline how to do the survey, so that to make sure this is probably related to the previous session we talked about the data. So we need proper data to make sure that this data can be used for everyone with the same standard. So, and I will talk a little bit later how we make use of this kind of data. So, as a team, we do survey, we do education local people. We produce the data that can be used for future to understand what has happened. And to share the data information among the scientific networking community, we also, well, I think many of you might join the IUGG next month in Berlin. And actually inside the IUGG framework, we also have set up what we call Joint Tsunami Commission. We have like 50 or 60 scientists in a team, where we also do like tsunami session every 4 years under IUGG, and every 2 years we change the host like that. So this is a way we share our finding and well research result. We just start since 1960, where we had a great earthquake in Chile, and also that produced tsunami reached to Japan after a day. At that time, we have no international warning, so that is another point of view that we have to work very internationally, especially for tsunami hazard. For our community, probably we started a bit later compared to earthquake. or volcano. In earthquake we have GAM, or for volcano we have they have GVM for tsunami as well. We also have a kind of community called GTM, which is what we call global tsunami model, where we kind of a network, international network of researchers from different university and institutions. And we were working with now it's UN. It used to be UN ISDR, but now it's UNDRR and the World Bank they support us how to we contribute our scientific result to the stakeholders and local people. Some of the product is something like, for example, the probable tsunami height for each area for different return period. And as Elon mentioned, introducing the last talk in this morning, 2004 Indian Ocean is kind of the initiative that tsunami should be more international. And as I mentioned, it goes everywhere where the water body is connected. And this, as I mentioned, this is the probably the first event in the record of many countries, including my home country in Thailand, where we have never such record of tsunami before. So that is why we had international survey team, as I mentioned in my first slide, that we go and measure the run up of tsunami height, and that can be used in the things that I would explain later on. And the right one is another one in 2011 that you might have know already, but you can see that we also again from the international team we could observe many thousand points of tsunami height that can be used for the to understand the mechanism of the earthquake. So this is an example why we have to measure or what we can make benefit from international survey team and what we can learn from this. For example, in case of 2004 Indonesian tsunami, again, it's not only one country, so it impacts many countries all over the ocean. So by knowing this kind of tsunami height, so we can do some reverse analysis to what is what should be the location of the fault, should be the location of the high slip area. And for example, if you use only the data on the east side of the fault, you could be able to propose a fault model of the earthquake that could reproduce tsunami height in the east, but might not be able to produce a nice a good match with the tsunami in Sri Lanka or India, for example. So this is kind of thing that we need more data and we need collaboration among the global scientists to get enough data to understand the hazard. For vulnerability or risk assessment as well, unfortunately, 20 years ago, we have less technology or kind of knowledge to arrange the data. Although we had many, we got a lot of damage in many areas, but we still have lack of survey and kind of technology to do the database. And for example, one example is that in Thailand we have less way to store the data, even though we have many thousands of damaged buildings, but in the database we have only just 100 or 200 buildings in our database. Or in Indonesia, we have no such a good collection of the data. So what we could do at that time, so we just classify the damage by using the satellite image before and after the tsunami and try to virtually classify if the roof is remain or not. And so we could not classify with the types of buildings. We only know from the sky. And but anyway, from this kind of data, we can somehow relate it. For example, the flow depths and the damage of the building. So once we know this kind of relationship, we can do more for the urban planning. What is the minimum flow depth that could destroy the building? Then we can do it better for the urban planning as well. For Japan tsunami, we have more data. We have, as I mentioned, we have like 5 of 6,000 points that we measure for the heights.
So by using this kind of data, we can again do the reverse analysis to understand, okay, where was the high slip or is the location of the fault rupture. So for the hazard perspective, we can understand more in this case, and for the vulnerability perspective as well, we improve a lot. For example, in the case of building data, in Japan we have a lot of data, and it's quite well organized. We know the types of building. And for example, then when we talk about the vulnerability curve, we can plot for different types of building or different types of structure or different type of number of stories. So by knowing more accurate this kind of relationship, we can apply this for urban planning. For example, this is the map of Sendai City, where we propose to increase the road elevation here to 6 meters to make sure that even though the water overtop the road, the flow depth behind the elevated road will be less than 2 meters, so that this 2 meters will not destroy the building, something like that. And how can we draw the conclusion or criteria of 2 meters? It is the fact that what we learn from the data that we gather based on the international collaboration or the data arrangement in the database. And last but not least, I would like to conclude that of course we need some scientific background to back up or to help for the things for the planning or the construction. But we also need to collaborate with like international organization or for decision making or practitioner. To do that, with UNDRR, we since 2016 we start what we call the World Tsunami Awareness Day, the 5th of November. Well, we can search later why was that, but I think we don't have time to explain about that. But yeah, so every year we're trying to making use of this kind of campaign to raise awareness of people around the world, not only scientists, but yeah, so we organize like the Tsunami Museum Conference, or we help the UNDP to promote the school preparedness or evacuation. Or during COVID, we know that it is, you know, I mean the action evacuation is more to save life is more important than to get COVID in the shelter or something like that. So we also try to help to make a guideline, something like that. And I would like to end my talk here with just a small piece of work that we could initiate while I'm doing my visiting in UCL with against with Fatima, that we again as an international community, we are trying to collect all possible vulnerability data in one database so that everyone can easily see and share. So this is kind of again we need international collaboration, and by having this by having these kind of things, we can apply to other areas and could help to understand the risk and qualify the risk and do more better planning for the reconstruction and future risk management. Thank you.
Thank you. Thank you very much, Anna, for the great presentation. So, I'm going to first ask the panel, are there questions for Anna? So, Carla, or Dan? Who wants to, Yeah.
Sure, thank you.
Please.
Just a quick one, which is how much does your work directly involve what we might call political buy-in? As in, are you operating in the domain of science, or are you also on the science policy interface on a day-to-day basis? Does the work you do require kind of constant engagement with policy and the administration and politicians, or are you generating evidence and understanding that can later feed into policy?
Yeah, so as our role, we are helping local government, for example, after the tsunami, when they would like to, for example, the 6 meter elevated road, we help them by doing simulation. Okay, what is the best height of elevated road that should be, okay. Of course, we can build 10 meters, but it probably not economy good, and also need maintenance things or something like that. So this kind of we help them as a support. We give like scientific data as a background for them to make decision making. But as I like my comment at the beginning about the warning, this is the thing that is actually happens, that what the government or local people thinking is different to things because they want to make sure that things will not be such thing will not happen. But yeah, they are not considered about the physical defense or something like that. Yeah.
Okay. Yeah, sure. I realized I was trying to formulate, it's probably quite a similar question, but I was curious as to, yeah, maybe it's a broader question of the target audiences for some of the outputs that you make. So particularly the one that you were speaking about at the end, like who do you hope to use it? So there'll be policymakers, but is there a broader remit of stakeholders you hope to use it? And maybe a kind of sub question about how do you share the data? Because presumably these are huge amounts of data. So how do you open up those data sets and allow them to be shared and used?
Okay. Yeah, I forgot to mention another big stakeholder that being using our data is the insurance company, insurance section. And yeah, so in general we share by publish the paper. So, and of course we share our statistical parameters so they can replot the same thing. Yeah, so in general we have two main users, which is local government, so that they can use these kind of things as a criteria to quantify the risk or damage. And of course the insurance company they use for them, but they cannot open their own things. But yeah, so but for this is for the vulnerability things, but for the hazard as well. So again, we publish our data as a maps, which is local government they will use by themselves, or they probably do ask some another company just to visualize or do some more simulation. But in Japan I'm not sure the situation in the UK, but in Japan every single, I'll say like county or local bureau in the website you can have an access to the different hazard map. You can download and see different, or some local government they put in the different layers, so you can check something like that. So this is kind of how we open our data. Yes.
Thank you. So questions from the audience? Yes. Yes, Mark.
Thanks for the very wonderful presentation. One general question for all of you, actually. My name is Mark Ojal. I'm from Kenya. So I'm happy to be here. The question is on challenges of the link between science and policy. If you are to consider the science policy interface as a cycle or loop, if you will, what do you see as the biggest barriers or enablers this loop to be complete? And the second part of this question is what do you see as the place of politics of knowledge? This is within the different epistemic communities, but also the north-south kind of relationships. Does it affect the way in which this loop is completed, whether it is?
Mark, can you repeat the last question, the second question, before the north and south, so that we understand? Yes.
Yeah, so here I'm exploring the place of politics of knowledge in either hollowing out or thinning the cycle of or the interface between policy and practice.
Okay. Thank you. So who wants to go first?
Okay, I can maybe relate it to, maybe I can mix up your first and second question in my one answer. So, well, at the beginning, I mentioned about the conflict between warning things, and another thing related to this is probably maybe answer your question. Is another point of view is the challenge that I'm facing or what I feel right now in tsunami community is that as a scientist, maybe you have heard an article like, okay, we expect this height of tsunami or of flood or whatever within this many XX year or return period or probability and the height, for example, which is quite difficult to non-expert to understand. You might understand, okay, when you check the weather forecast, tomorrow is probability to be sun or cloud or rain. That will be more easy to understand. But if we talk about, okay, we expect to have magnitude of 7 within 500 year or something like that is quite difficult. But once when we talk with local people or like industry owner, they ask for different things, which is like, okay, if the earthquake happened in this point, will tsunami reach to my industry, factory, or should I evacuate or something like that? So for my research right now, I'm trying to change my way to visualization or to show the result. We're doing the same thing. We did many simulation, many case to get the output, but the way we convey the output is that we try, okay, let's focus on one area and let's see if from our result, from our simulated result, if what is the point of the earthquake that will definitely produce tsunami to this factory or something like that. So that this kind of once we have this kind of data, so we can help support the decision making of the factory, that okay, they can see that, okay, from the map, if the earthquake happens in this area, they might have less priority to evacuate or stop the production or something like that. We use the same thing that to produce the height and probability, but just try to use the same data but adapt way to convey or communicate with the decision maker or local stakeholder. Thank you.
Yeah, so I think on the barriers and enablers, I know I spent a little bit of time on this, but yeah, in terms of the critical ones, there are definitely some elements of kind of language and culture institutionally between science and policy, which I think maybe that's a bit tried to say that's the biggest one because it's everything, but I guess the artificiality of those as well, and the fact that we've kind of probably proven at various points throughout today that many of us we're not just scientists, we're not just policymakers, we're not just citizens, we all overlap across all of those things. So as I said, kind of clumsily, we're making a caricature of the science policy interface because we're all more nuanced actors within that, and all of those systems are more nuanced. But yeah, there are definitely things that we've perhaps preserved within the practices of doing policy and the practices of doing science that have made us talk across one another. Hopefully, there are opportunities in these science policy interfaces to reconcile that to some extent. I realize one thing I didn't say, and this is absolutely not a perfect answer, but something which I find encouraging, that especially global interfaces like ITBES are doing, I'm not going to say the whole name again, is from the beginning and actually increasingly, it's been very intentional that Indigenous and local knowledge is part of the assessments. So it's not Western science, it's supposed to be an integration of different kinds of knowledge on biodiversity and ecosystems that goes into that. And that's in everything from the global assessment to things which have come out much more recently. There was a values assessment that came out last year, which is looking at methods and practices for the very different ways in which we, as a global community, understand the value of nature. So I think things like that, it's not perfect, but to see the effort going into it and the attempts made to do this and to integrate and communicate the variety of different knowledges that we need to appreciate and act on is encouraging. So I'm going to say that's an enabler or an opportunity.
Thank you.
I think we've heard from the experts on that.
Okay. Okay. So thank you very much. I mean, we are actually coming to the end of this panel session, and obviously it's very tough to compete with ChatGPT for providing you with a summary of this session, and I'm not even going to attempt. So there is not much time. It's just that I would just maybe spend some seconds to just say that maybe it all comes down to trying to ask the right questions at the right time, and because that is going to set our priorities as scientists on what we are going to focus on our energies. And this is totally something that I guess cannot yet be done by artificial intelligence, to ask the right questions. So I guess we take all that privilege to us as let's say, people, not just scientists. And obviously, I would also like to refer to, in the morning, we heard about pipelines. Clearly, pipelines are very important, and it's also important to think about pipelines of knowledge that connect us all together as people, first of all, and as scientists. And obviously that kind of emphasizes the importance of open science and open data, because that is one way of empowering everyone and kind of trying to focus on the different velocities that can exist in the advancement of science, and focus between the north and south, global north and global south divide, would be to try to bring the knowledge as far as we can, more than the tsunami waves, hopefully. And with that, I really thank you for your attention. And thank our excellent panelists for the great insights and the great discussions. Thank you.
Thank you. Particularly thank you to that panel. And that brings us towards the end of our day today. I was just trying to reflect on what have we learned today? What have we discussed today? What's our mood now compared to where it was at 9 a.m. this morning? And I think particularly in the morning, but sort of in the afternoon as well, a key message was be an optimist. If you don't try anything, you will not do anything. That came out very strongly in our talks this morning. There will be challenges. Things get in the way, borders, barriers. But let's try. Let's try and make a difference. Let's try and keep going, do the best research we can, do the best engagement we can, work across these barriers, work across these borders. Another message that came through was there are initiatives that do work. Three figures. Things can actually happen, things can work. Particularly in research, particularly in academia, we are trained from the beginning to criticize. We are trained from the beginning to find the flaws, to find the faults, to destroy, the work that we all do and find every single possible thing that could be wrong with it. If we actually want to make a difference, sometimes we have to accept that an initiative, an idea is not perfect. That again came through very strongly this morning, and again talking about the politics this afternoon. An initiative may not be perfect, but if it's good and it has good impact, and we can monitor and evaluate that good impact, let's try it. If we can come up with new, better ways of doing things, fantastic. And if it doesn't work, let's stop and move ahead. But we don't need to reinvent the wheel every single time. And that implies to both things happening now, but also learning from throughout history. And let's learn from history. Let's not repeat the same mistakes time and time again, and from different regions. We also saw that initiatives, interventions, and even disasters themselves may not cause a change, but they could be a positive catalyst, they could be a positive influence. So even if it's not the fundamental cause of the change, we can still use these things to help along, to improve, to make positive influence. And one of these things that perhaps we could make a difference with, and to question what is the role of technology, AI, digital twins, ChatGPT, what is their role? What are the barriers? What are the borders? And I was thinking one of the borders is between the human and the AI. Geopolitics has come up a lot today. It came up a lot yesterday as well as something, a really big barrier. So maybe that's something we all need to think about. People in the room, people online, communities, everybody working in the disaster space. What is our role in geopolitics? What research can we do? What evaluation can we do to try and move the dial? We're not going to solve that tomorrow, but what can we do? What can we show? How can we influence? How can we improve the situation so that those with the power are more interested in sharing it and not trying to cling on, as we discussed yesterday and today, in different geospheres, different political spheres, different geopolitical spheres. But what can we do? And particularly at the end, I think we really focused on the importance of asking the right questions. And yes, ChatGPT might have summarized a session, but it didn't ask us extra questions. That's what we can do. We can find the next questions, we can ask the right questions. And that is somewhere where that's still our role. That's something we need to do. And let's make sure, as I said at the beginning of the day, that in 5 years' time, we've got a new set of questions. We're not still asking the same questions that we're asking today. After we've closed this session, we have our posters from PhD students and others in the foyer. We're talking about what research we're doing. We're talking about what questions can be asked, how can we be improved. These are the next set of bright minds coming through, so do go and speak to the PhD students about their posters. For prospective students who are in the room, or not those online because I'm afraid you're not here, but those of you who are in the room, do come and find Roberto Gentile, if you wave your hand, and he can talk to you about the programs if you've come to talk to him. And I just want to say, finish with a huge thank you to all the speakers. I've learned a lot. I think everybody in the room has learned a lot. To all those behind the scenes organising, it's a huge amount of work over the last 2 days, so really appreciate all that work. And to everyone who asked questions, or to those of you who sat quietly and just absorbed. So thank you to everyone. It's been absolutely fantastic. Continue to enjoy yourself, come to the reception, and we will see you not just at next year's event, but at all our events in the meantime as well. Come and work with us, come and collaborate. So from everyone at UCL IRDR, thank you so much for being part of today, and those of you who were here yesterday as well. And at that point, the conference is closed. Thank you.